Okay, so the agenda today is two things. We've got just one problem to do today. The lab this week was going to be really short. So what I did is I combined it with the lab we're going to do next week with mirrors. So you have a lens and mirror lab kind of next week. So it's kind of a funky week. We're off Monday. I see you guys not Tuesday, but Wednesday, Thursday, Friday. So look for day one that week, Wednesday, to be like a lab day. Then we'll kind of wrap up the chapter. So tomorrow we're doing mirrors. Day one's gonna be a lab day. Then day two and day three we're gonna wrap up, review early the next week, and I would imagine a test either Thursday or Friday the following week. Kind of makes sense. Likely Thursday. I don't like to do tests Friday afternoon, just in case. Okay. So you've got one problem to do tonight, and then we'll do mirrors tomorrow. And we'll be in good shape. My only lesson today is to go over these 20. If you have questions, please let me know. When a ray of light passes from air to glass, we should know that what is constant? From air to glass, what's constant? Frequency. So V equals lambda F. Generally, what varies all light? What is the difference between red and blue? Generally, red is this, while blue is this, because this is what's constant. But if I isolate just a red laser or just a blue laser, in that case, when I do V equals lambda F with just blue light, what actually stays constant is this. So then as this goes down, this goes down. Is that okay? So frequency is what's constant as I go from one material to another. This one is a great question for you guys. Why? Because it's not super difficult. It's graphical. This is this is what the kind of stuff you see on College Board. I mean, obviously these are all College Board problems. I try to do pretty high in terms of their alignment to the exam. Why is this one so good though? Because I want to say that slab X has got the bigger n value. I want so badly for slab X to have the bigger n because it's got the bigger slope. But I've got to be careful. So for instance, n of X, well, I want to do X. Let me set up my equation. N1 sine theta 1 equals N2 sine theta 2. I want to be really careful. What gets students in trouble is when they say to themselves, I remember this question, and this is the answer. Because often College Board will be like, I remember this question, the answer is like the opposite or the inverse. Watch what happens. If my equation is N1 sine theta 1, if I look at the slope, which would be sine theta 2 over sine theta 1, so sine theta 2 over sine theta 1 is my slope. Fair? Right? Because rise over run. But if I do that, if I look at the equation, that means the slope is actually what? N1 over N2. So in that case, if I go from say like air to that material, laser beam is shown on different slabs of different material. I have my incident angle, my refracted angle. In this case, it's actually the opposite. Slab Y actually has the bigger index of refraction than slab X. Is that kind of okay? Because I'm assuming in each case, like for instance, with slab X, sine theta 2, or really slope, equals 1 over nx, or slope equals 1 over ny, if that makes sense. Because in each situation, my N1 would be maybe air as I go into that material. Right? So like 1 sine theta goes in sine theta. So in each situation, the slope would be 1 going from air over N2. But what that means is that really N is the inverse of the slope. So Nx would be 1 over the slope. Or Ny is 1 over the slope. Is that enough for that?
Sine theta 1 on the y.
So if sine theta y, good. If sine theta 1 is on the y and sine theta x is on the sine theta 2 is on the x, then bigger slope wins. Does that kind of make sense? That one's really tricky, right? So what I have to do is always go back to this. And if it's theta 1 versus theta 2, sine theta 1 versus sine theta 2, then my slope actually is in. It's okay. Assuming I went from an index of 1, assuming I went from air. But what happens often is that our gut tells you it has to be A. And I'm going to tell you most of the time, go with your gut. But I would also just be sure the math doesn't lie. This is how they get students though. Okay. Because they're going to make you really own this stuff. And it's a little bit tricky sometimes. I didn't have to know anything really new. Like, I mean, all I have to know is Snell's law. I do have to be able to kind of manipulate it a little bit. All right. Next one. D. Some of these will fly through. Some I'm going to take a little bit more time with. Here's the deal. I don't need to be able to calculate it. If all the angles are smaller than my initial angle of incidence, guess what? I'm going from a lesser end to a bigger end, period. If all of my angles were bigger, then my angles of refraction were bigger. I refract out. I'm going from a bigger end to a lesser end. I don't need to know what the average n is or what that actual n is, but I can clearly tell going from 15 to 9.9, 30 to 19.5, 45 to 28, 60 to 35, that I'm going from a higher end to a lesser end to a higher end as I refract closer to the normal each time. Anybody? This is also the time, because we're kind of in review mode. We're beginning to get in review mode for the AP exam. If there's a concept here that you're like, yeah, I'm not seeing that. Please, let's have that conversation, right? So, Maria, thank you for your question. If you guys have a question, like say like, hey, look, because we're going to do this test. This is partly for the test, but it's also kind of our review for May. This is a lot of what you're going to see in May. Next question. Negative 15. We good there? So the resultant image formed by the lens has is virtual and has a height of 3 centimeters. Well, first off, it has to be virtual. I don't know of any image created by a diverging lens that isn't virtual. What's the focal length of the lens? Well, remember, 1 over f. I'm going to go ahead and solve these for anybody. Again, not here, not negative di. I need negative f though, right? Negative f equals 1 over do plus 1 over di. But here's, I suppose, why they reiterate the fact that the image is virtual confirms that it has to be a negative di. We talked about that the other day. If you remember your notes from the other day, I said if you ever get a negative di, your image is virtual. Somebody asked, how do I know if my image is virtual? Well, one, if you're tracing back physically, but also if you ever get a negative di, that means that's virtual. So what I really need here is to be on the right problem. 1 over negative f, so that's what I'm going to solve for, equals 1 over do. Do I know do? Nope. Do I know di? What do I know? The bulb has a height of 9 centimeters and is 30 centimeters from the lens. So I know DO. But I don't know DI. So if I don't know DI, I may have to go to this. Well, my mag, if my height should be 9, but it's only 3, what's my mag? 1/3 or 0.33. So that equals negative DI over DO. So this is a little bit more complicated problem. So my DI then is a 10. And something's going on here because I don't have the right answer. What did I do wrong? Helping him. Oh, no, maybe I did. Yeah, no, I'm good, right? 1/30 minus 3/30, 2/30, negative, flipping them 15. Good. Okay. Any questions there? Good, we good? All right. What in the world? This one is super tough. The reason I think it's super tough, it's confusing to me. The reason I picked it is because you're gonna see it on an FRQ pretty soon. Not today. Anybody get it? And can explain it?
Well, we didn't think, we ruled it, well, I think process of elimination.
Yeah, it can't be the slope,
Yeah.
right? Like with the slope, would be 1/DI over 1/DC would be like DC over DI, which is DO or DI, and that'd be like a mag or something.
Yeah,
Inverse of mag. So A is nothing.
the access intercept is one over the values, so I guess. That's what they did with that.
Which one? The axis of the axis intercept of either.
It's just because that is one over.
Right.
So
that's no good. The absolute B could be the magnification, I
Okay.
suppose, but that's not the focal length. Here's one thing, like mathematically, if it's 1/F equals 1/DO plus 1/DI. What if I say 1/DI is 0? So if 1/DI is 0, that means 1/F equals 1/DO. So F equals DO. Also, on the same token, if I make DO 0, then 1/DI equals 1/F. There will be an FRQ coming up where it's going to say, hey, what is like the x-axis, the intercept? What can you do with that? Or how could you find the focal length? This is kind of the answer to that question. When I hit the axes for either one of these, that means 1/DO or 1/DI is 0. And when that's true, then 1/F equals 1/DO, or F equals DO. So it kind of makes sense. But you're right, you can do process elimination, which is, if you guys ever have a problem that says pick 2 answers, it's almost always easier to rule out 2 than pick 2. There's always 2 that are like, there's no way. Can't be. We haven't hit that yet, but there will be as we do test prep, that kind of question.
They have to 2 of these.
Yeah, there's like, of the, say, how many questions you guys have? 50? I think 5 of them are pick 2. I'm not a fan. But I will say, it's much easier for me to pick 2 that are not than to pick 2 that are. Okay, this guy. I don't see the answer. Oh, that's the, no, that's not the same one.
I think the next page will have.
Yeah. Okay, so here we go. I need, there's my object, it's diverging lens. I got 3 options for rays. So you guys know this, right? So folks at home, You can go here and you can go away. You can go through the middle. Or you can go towards the far and come out parallel. Those are my three options. When I do a diverging lens, I can go parallel and away from the near focal. I can go through the center of the lens, or I can go towards the far, but come out parallel. Those are my only three options. So when I go to my next page, A would be great for a converging lens, but it's not. B is absolutely nothing. And D is absolutely nothing. So I have to recognize that only A and B are even, A and C are even possible. And A is for converging, B is for diverging. C, did I say that? C is for diverging. Okay? Oh, there's a question. Number 7, 20 questions. Let's crank through it. When an object is 9 centimeters from the convex lens, a real image is formed 18 centimeters from the lens. What's the focal length? This might be one of the easier ones. This is like super easy, right? 1/18 is convex, so there's no. I do need to know that convex is converging for a lens. I do need to know that. So sometimes when they don't give me a diagram, like that's a little bit tricky. I need to know that convex is converging, therefore there's no negative F. So it's just 1/F equals 1/, whoa, that's not F. What is the focal length? 1/F equals 1/DO plus 1/DI. And notice how they make it to where you can do the math very easily in your head. 2/18 plus 1/18 is 3/18, flipping them 6. Bill, do you get this one? Sound back. What in the world?
So,
That I would say that's gonna be false. Flipping them. It's okay. Did you get it? Come on, kids. Focus.
yeah.
Yeah.
We're giving-
6. Okay. Now, there's another one, right? An object is located at 8 centimeters. So let's crank through these. 8 centimeters to the left of a convex lens. It has a focal length of 10 centimeters. Where's the image formed by the lens? Okay, so here's the deal. If this is 8, this is my red flag one. Draw it out if you have to. That means this is 10, right? And so if I have a converging lens and it's converging, convex, and I'm inside the focal, that's my red flag. If this is diverging, the image is going to be somewhere right in here. Upright. But it's not, right? So because this is converging, this is going to be the one where, and I didn't draw this very well in terms of my diagram because it's other rays going to be hard, but this is going to go like this, and it's going to go through over here. Long story short, it's going to be the one where, yeah, I kind of missed that, didn't I? It's like we have to draw back. I missed those, but it's going to be back here. The point is, and this isn't very well drawn to scale, if you're ever inside the focal for a converging lens, it's the magnifying glass. The image is upright, virtual, and huge. Inside the focal for a converging lens, upright, virtual, and very big. So back on the same side. So I go to my answers. Oh, did it give me numbers? Oh, it did. Yeah, so to finish that off, I'm going to have 1/F equals 1/DO plus 1/DI. So I guess I went a little bit too far with that whole discussion, but DI ends up being 40. But specifically, it's not just 40. It's negative. So what does that mean in terms of, I think what they're doing here is they're trying to say, what does that mean for you? Like, it's gonna be a little bit tricky next week, because next week, when you do a mirror, or even tomorrow, for a mirror, ending up back on the same side is actually a positive thing. It's what the light should do. It's when I get an image inside the mirror that I get negative. But my point with the drawing is that I would expect to be back on the left side of the lens. Which is why the negative DI comes in. You guys still with me? Most of us? Okay. All right. Now I just place in the axis of a converging lens, focal length 2, distance 8. The distance between the image and the lens. Oh, is this another easy one?
Yeah.
Come on, man. So 4/8 equals 1/8 plus DI, 3/8 flipping them. So again, they do a lot of these so that you can do the math real quick in your head. Save you some time for some of those longer problems. So 3/8 flipping them 8/3. Right? So I would get 3/8 equals 1/DI. So DI is 8/3. And you know, in physics, we typically reduce that because fractions are evil. Kind of with me there? What I like to think about too, and this is not to like, I know sometimes you're going fast on these or whatever. I will point out that there are, like, as we get into exam review, there are questions you gotta get, ones you probably should get, and ones you're just not gonna get. You're gonna take the L on. That's just the way it goes. That's why 60% or so is like 65% is a 5, right? That 35%, you just take the L on. But the ones that we've got to really work on is that 30% or so that we've got to get, or 20% that we've got to get. This is one of those you got to get. It's a converging lens. I don't have to worry about the negative. This one I've got to get right. So we missed number 9. Let's check on that guy because that one's a straight up. Every now and again we get an easy pitch. You gotta swing. Here, this problem I think is one of the more confusing ones. This is the one that maybe that 25-30%. That who knows? Me personally, I'm gonna narrow this down to A or B. Why? Because when you walk around the pool, there is really no point where you can't see in. Right? Imagine walking around the pool and you got Smack swimming on the far side, the bottom. I mean, it's all over the place. Wherever he is, you're going to see some version of him as you walk around the pool. Right? You can kind of see that around the pool. It's only when I'm in the water looking out that I start to see places where things look, maybe I see that internal reflection. I think what's confusing though is somebody might say, hey, look, you're over it. This is me. I might overthink this. Say, hey, look, I wouldn't see the ray from the sun that went down, reflected, and is coming to me like this. I wouldn't see that because it would refract away, right? But I would see this one. So remember, what I have to understand is that there's an infinite number of rays coming off this guy, and I may not see this one, but I am going to see one of them. So that's where I start to, me personally, I'm going to overthink this. Right, so I'm gonna say, hey, look, I am probably not gonna see this ray coming towards me because it might even reflect back down. But remember, there are rays reflecting off the diver up, here, here, here. One of these rays I'm gonna see. Maybe it's that one. So I may not see this one, but that's not what they're asking. They're saying simply, will I always be able to see? And there's really no point at which, now what am I going to think? I'm going to think this guy is right here. Always going to look shallower. I'm going to walk around the pool. They're always going to look shallower than I think they are. Always shallower. The person's always deeper than I think they are. They're going to look shallower, but I'm always going to be able to see them. At first glance, though, a lot of people are going to put no for this. But we're thinking about that one ray that's never going to come back down. This one says, And we forget that there's an infinite number of rays coming off it. It just wants to say, hey, can I see the person? Sure. We're okay. PS, some of you guys did really well on this. There's a few scores that are pretty legit. I don't see many dark green. There was a few dark green this time. A lot of light green, few really dark green. Usually we don't get dark green. So, all right. So if you, the point with that is if there's any in that category that like, hey, I still don't know this one question, let's talk about that. For instance, this one. Every now and again, they do this where it's like lights in air and then they like submerge the prism or they make it backwards. All of a sudden the prism is full of air and they submerge the whole thing in water. So that can be a little funky where things do the opposite of what you want them to do. Here's the deal. As long as I have different N values, the light's still going to spread out. It's still going to separate out. But remember, you get the biggest bending when the difference in N value is the greatest. So for instance, if I'm going from like air to an N value like in a diamond of 1.7. Well, no, I was just saying like this is some funky, like sometimes you get some weird stuff. That's just like side discussion. The prism is, I think, solid.
Yeah. I don't think. Never.
The prism is a glass aquarium. So initially this is air. This is always whatever acrylics say. Actually, it tells us. In value of 1. So it goes air is 1 and this is 1.5 initially. Then all it does is say, hey, look, the prism is still 1.5. But we're going to put this in here with water, and now this is going to be 1.3. The point is, when I go from an N value of 1 to 1.5 or 1.3 to 1.5, I'm still going from a different one N value to another. The light's still going to bend. But I get the most bending when I have the biggest difference in N values. If you believe, and this is where I need your input, guys. I know I'm just the one talking here. I'm not moving around because I'm stuck to the computer. But if you're like, hey, look, I really thought it was C, let's talk about that. D. So how about this? If I went from air and the prism was filled with air to air, what would be the separation between the things? Nothing. What if I went from water to water, like 1.3 to 1.3? Nothing. So what happens then is that if I go from if I go from 1 to 1.3 versus 1 to 1.7, which one's going to yield the biggest bend? 1 to 1.7. So whereas my N values are the biggest difference, and this is an essential thing in physics for the entire universe. Everything in the universe moves when there's a difference. Charge. If I have one hand at 10,000 volts and another hand at 10,000 volts hanging on a wire, what's the difference? Nothing. So the charge doesn't want to go through my body. It's when one hand's on 10,000 volts and my foot's on 0. That gets tricky. Or in thermodynamics, 98.6, 98.6, what's the difference? There's no movement of heat. You get the greatest movement of anything that I can think of when you have the biggest difference between like entities. So in this case, the bigger the N value difference. My first difference is like 0.5. I went from 1 to 1.5. Then I'm only going from 1 to the point where if I went from 1.5 to 1.5, you'd say the difference is 0 and there would be no bending at all. Is that okay? How do we do on 13? We're getting there. 12, did I miss 12? Shoot. So it places a 40 centimeter, a lens with 40 centimeters from an object. Excuse me. Observes in a large image on the screen on the opposite side. Okay. For those of you guys that had optics and honors, maybe this is a little bit more ingrained in your head. if it's a diverging lens, A and B, I can only have a small upright image on the same side, period. So I've got to kill A and B. So back to it. Sometimes it's easier to get rid of stuff. So A and B have to go away because diverging only creates small upright virtual on the same side as the lens. So what could be on the other side? Well, converging lens of focal 30 or 50. Well, if I place the object 40 centimeters away, but my focal is 50, what if my object's inside the focal? Does that create an image on the other side of the lens? No. So I kind of have to rule out A, B, and D because A, B, and D all create images on the same side of the lens. So if you thought those, remember for my converging lens, and I know we've still got some here. If I'm outside the focal far, you're upside down and small. As I get closer, as long as you're outside the focal, you're still upside down, but you're getting bigger and bigger and bigger and bigger. To the point where this one, what would this image look like? For those. Right, so like if I am just outside, let's zoom in and doing this one. If I am here with my focal and I am just outside the focal, like right here, what happens? This goes here and through the focal. This goes through the focal. Notice how they are converging, creating a real inverted enlarged image on the other side. You can actually, and I know you guys don't have a ton of time, except if you save some time on some of those like easy pitches, you can always draw these out real quick. Right? What would it do? If I have a 40 centimeter object and a diverging lens inside, now diverging I gotta kill. Because diverging is just not going to create an image ever on the other side of the lens. But with the converging, what if I'm inside of it? If I'm inside of it, that's when I get that image like back on the same side, right? I just can't. Okay. All right, 13. You saw something different, argue me. How about this is helium and this is air? What's the answer? A. The thing with B though, I like where your head's at bit with B, but remember, it's always measured to the normal. So this angle is actually smaller than this angle. Well, I mean, I said right. Yeah, I didn't know it's smaller. If I'm going from helium back into air, it should actually get closer. So it would be reverse, my point. Right? So angle blue is smaller than angle green, which would be fine for going from air back into helium or something. My point is sometimes they'll reverse it on you. I think the answer for this has to be A or E. I can't imagine a situation where it's not A or E. So if I need to visualize that though, as light and it just, I mean, C is just not going to work unless my n values are the same. So then which way does it move? Well, if this is my theta initial, I need, if I'm going from, oh, does it tell me what path is medium? Oh, one is one is air and 2 is glass. So that tells me that this is the bigger one, right? So in that case, that means my angle has to be smaller than green. So I know it can't be C, so it's got to be D or E. So really, you guys should be picking only D or E possibly. Now, what happens then Because that's the easy part, is getting in. What about when I get over here? I need an angle that is, if this is my angle, it's gonna be bigger than that. Well, D got smaller. I tell you, rarely will you see this like V looking shape going on. Yes, that way. I guess it is V the other way, but I don't know. It's gonna bend away. Okay. That makes sense. 14, few more. King, if you saw something else here, help me. You know that a converging lens will create a bunch of different images. If you're inside the focal, it's upright, virtual, and big. So I know that 5 and 10 are inside the focal length. Gotta be. Once I get outside of that, then I start to be inverted. So if I'm really far outside the focal, I'm inverted real and small. As I get closer to the focal, I'm getting closer. It's gonna get inverted real and bigger, so it's gonna get bigger. But somewhere between, look at where it goes from upright to inverted, and there's your answer. That no image occurs at the focal, which is somewhere between you being upside down and now upright. I don't know where, but it's gotta be between 10 and 15 centimeters. Just a few more. Oh, we still got that one too. I actually solved that other one finally. I got it right. We got 53 degrees-ish. We'll get to that in a minute. Angle of incidence, theta 1, the angle of refraction, theta 2 are measured in the graph shown is created by the data. Based on the graph, which the following diagrams represents the possible path of a light ray. Blah. So, what are my options here? The only way I know which way it's going to bend is if I know the in values. A means they're the same in value. B says that material 1 has a smaller in value than material 2. C says the opposite. And D is not an option. D is reflection of some sort, but it's not even right because theta 2 doesn't equal theta 1. So D is a bunch of ish. A is the same in value. It's either D, B or C. Now, how do I know which? So Rebus, this goes back to yours, and this is where we're going to get super confused because like we just did it a minute ago. Now we're doing this one. N1 sine theta 1 equals N2 sine theta 2. This might be the opposite of what we just did. Right? So I don't want to ever guess though in physics. There's no reason to. So my slope is going to be sine theta 1 over sine theta 2. It just takes a second. You've got 2 minutes of problem. You can do this. Sine theta 1 over sine theta 2 would be N2 over N1. There it is. What's that? So here's the deal with that. What does that even tell me? If N2 is bigger than N1, my slope should be greater than, how about if N2 equals N1? What's my slope? 1. Fantastic. So if N2 is greater than N1, my slope is bigger than 1. But if N2 is smaller than N1, that means my slope is less than 1. No, I don't know what N1 is. But I just need to know how N1 and N2 are related to each other. So that's a great question. Because you're right, like we solved that. Awesome. What does that even mean? Right? I have no clue. If they equal, my slope is 1. Here, is my slope 1, less than 1, or bigger than 1? Less than 1. If my slope is less than 1, right? Because look, I mean, look at your slope. It's like unless my scales are off, you be a little careful because sometimes the axis could be wrong and then you're really kind of like, skirt. But even like, if I look at my slope, I don't know. I'm trying to figure out a good place to calculate the slope. Like that, something. Right? 4 blocks versus 3. My slope appears to me to be less than 1. I kind of drew that up a little bit. I got a little bit.
M2 over M1.
What's that? So that's just the slope. But my point is though, is that since this value is less than 1, that means N2 is smaller than N1. Does that make sense?
Yeah.
So I don't know, but I do know that N2 is smaller than N1. I don't know that N1 is there. No clue. But I do know that N2 is smaller than N1. So this I thought this is one of those I would love for us to get. You might not get it. I don't think it's one of those impossible ones. A little bit of a reach. But maybe on the next time around it gets easier. Physics seems to always be easier the second time around. You're like, oh yeah, I totally understand how to do this now. It's like a hindsight thing. But the only way I'm going to know this is to know which n is bigger than which n. So how can I do that from the sine theta graph? I found the slope and I realized that the slope is, if it's 1, the n values are equal. If it's less than 1, then n2 is bigger. If it's greater than 1, then n1 is bigger. So okay? If I say that right, if it's less than 1, n1 is bigger. If it's greater than 1, n1 is smaller. Okay. So here I know that based on that, what did I just say? Let's make sure it makes sense. N2 is less than N1. Okay. So if N2, this is a pretty tough problem because you had to go from a graph to refraction. But this clearly shows to see B, N2 is bigger than N1 because the angle got smaller. That's pretty hard, right? Because you're like, even if you got that, you're like, well, 2 is bigger than 1, so maybe, or the other way, then you start to flip in this. Okay. 34 degrees. Need to calculate it? We good? This one's going from glass to water. So calculate this bad boy. It's going in. We want to know what is the angle of refraction for the beam as it passes back into water. So I'm doing Snell's law, N1 sine theta 1 equals N2 sine theta 2. This is a little bit tricky, but we can get this. I'm in glass. So 1.5 sine of, yikes. What is that angle right there? Well, we've been down this road, right? Because to find that angle, so follow me, how did I do that, right? So like, here goes my ray, and it wants to go straight, but it's not, but there's my ray. I'm going to draw my normal, which is 90 degrees at that point. Since I'm going into less dense, I'm going to start doing that. So I want to find this guy. But how do I find that red angle? I would do 360 minus 90. Call that 1. 90. 60. And maybe another 90. So this is like one of our classic prism problems. I've got to find that little angle and I'll make it yellow. I need this guy. But this is one of those middle problems. It's not the easiest pitch in the world, but I feel like this is one we can get. We need to get. You need that yellow angle and you win. Because I'm just going to go, now I got to be a little careful, I'm not going into air, right? So I am going into water. So what angle is that? 270, 330, 30? I don't think that's the easiest pitch in the world, but I also don't think that's one of the like, we're going to take the L on. I think that's one we need to be able to get. If you don't like the four-sided object, the triangle up top, 90 plus 30, because it's a 30, 60, 90. 90 plus 30 is 120. From 180 is 60, and I always want the angle measured to the normal, right? So it's gotta be 30. So then if I do 1.5 sine 30. I get that. Cool. None there I could really rule out, I think, in terms of like, I don't know if there's any like right off the bat, it couldn't be. They all seem to be bigger than my angle that my 30-degree angle, so I don't really know, but D is a stretch, like anything getting into that huge of an angle. Okay, we're almost there. All right, this guy. Okay,
You know,
what did I do here? So if I'm doing critical angle, and this is air, do I know what the other stuff is? Liquid. Anybody figure this one out?
no.
So
But-
let's look. In sine theta critical equals 1 sine 90. What else do we know? I also know that you thought?
So I feel like based on, I'm trying to think of what it would be. Would that mean that there would have to be less than n equals 1 because of the slope is greater than 1?
Oh, slope is it? Oh, yeah. slope is-
Yeah, so okay, good. So the liquid, yeah, the liquid would have to have a in value that's, what do you say, greater than 1. So with these are the ones where I start to try to figure out like some relationships. Right now I know that also 1 sine theta air equals n sine theta liquid. So this is where I kind of start to hope that things like open up for me. I'm just making true statements and just trying to play around with the math a little bit. I know that my slope is also there too, right? So I could try to figure out what that is. So I know that, how about this? My n value up here for that material, that n over 1 would be sine theta air over sine theta liquid. There are times where you just play with the math. Is that kind of okay? And this sine theta critical is up here, but now we've got the slope. So if I were to plug that in, I get the slope. And maybe this is what you guys try to do. Times sine theta critical equals 1. So this is where I start to get close, because it looks to me like sine theta critical is going to be 1 over the slope. So follow me again, and because I may have lost you. One thing I know, and I tell you guys, the farther you get into physics, it's like the less you know, like it's so frustrating. Physics at some point becomes like I told you this, like walking in a dark room and you just hope that as you write, it just starts to like get a little bit like your eyes start to adjust a little bit. So I know a few statements. I know that N of liquid, sine theta critical is equal to 1 sine 90. That's my one equation. This is me, I just started playing around with stuff. Another relationship that I am sure of is that 1 sine theta air equals in liquid sine theta liquid. Is that kind of okay? So yes, no? So then because the air has an index of 1, my N for the liquid is really just my slope. I just moved this right. See this? Yep.
Yeah.
N for liquid is equal to your slope. So then if I go back to it, where did this come from? My right here, back up to the top. If I plug this in up here, that's where I got my slope. Really, times sine theta critical. I don't know if I plug that in right. You guys see that? Like, this is my slope,
Sine theta air
and that's this guy.
times sine theta.
And this is all just 1. So if that is my slope times sine theta critical, let's see if we get the closer answer than today, because yesterday we were getting like 48 degrees or something. This is just 1. If you go back and wrestle with this later on, these are the 2 things you're wrestling with. And slope. So 3 things. 1, 2, and 3. And how can I kind of connect those? So what I end up getting is sine theta critical is 1 over the slope. Dylan, you okay when we write it again? When we write it clearly?
When you look at the graph, when you-
So now I just got to kind of calculate a slope that I think makes sense. So if I do, what's a good point? Maybe like this one even? I would probably pick like those. 0.4 over 0.5. So follow me again. I just came up with a couple equations. I know that 1 sine theta air equals N liquid sine theta liquid. I also know that eventually I have to solve this guy up here. N sine theta critical is 1 sine 90. And then I've got, well, how does the slope factor into that? Well, I can look, yeah, it's a little bit tricky. I can look right here and see that sine theta air over sine theta L is the slope. So all I did was I created equation 1 and equation 2, and then realized that my slope is actually in here.
It's something graph.
So then I just kind of, what I did is I look and I say, okay, based on like a best fit line, my slope looks like it's about 0.4 over 0.5. 0.5 over 0.4. No, come on, man. That's 1 over. Come on, bruh.
No, that's what I was.
Is that okay? Come on, man. So 1 over the slope ends up being 0.8. So the point is sine theta critical equals 0.8-ish. So theta equals inverse sine of 0.8. What do we get? Is that 49 for that one?
No, it's 53.
I got 53 when I redid it. So yesterday I got around 48. and I kind of approaching it a different way. I went back and wrestled with it a little bit, and I came up with this. The slope is 0.5 over 0.4. But I think what happened was if we use that, we might get the 48. I had to realize that my sine theta critical is actually 1 over the slope.
Okay.
You sure we made the mistake? I know that was long-winded for that, but my sine theta critical is actually 1 over the slope. Right. Do you see why? Maybe?
Oh, yeah, I had put 4, but that's what.
Yeah, okay. It's because again, my in value is sine theta air over sine theta L, which is the slope. So my in value is the slope. So then when I plug that in, my in value is the slope from sine theta critical equals 1 sine 90. So that's why it's 1 over. I'll finish it. We got one more? No. We have 3 more? No. Shoot. If we go tomorrow, we're good. This one's super easy. It's just flipping them. I know equal like. What is the ratio of V air to V glass? I know that normally N equals C over V. Right? So for each one, which means that for each thing, N1 V1 should equal N2 V2 because for my other one, for the other N, it also equals C over V. But C is a thing that's always constant. So you could argue that if for one, N equals C over V, and for the other one, N equals C over V, then N1 times V1 should be the same amount. Now, V1 might be smaller, but that's because N1 is bigger. Or N2 might be smaller, but that's because V2 is bigger. Right? So those have to equal. So then if I want to create a ratio, the index is a refraction of air to glass. So then check it. I need to be able to be careful again. This doesn't look like a ratio right now. But that means N1 over N2 has to equal V2 over V1. N1 over N2 has to equal V2 over V1. This is the kind of stuff we got to be able to do on the board exam. And I think the biggest thing is that we get tired after a while doing it. You just got to be kind of ready to go and just sprint and do the best you can. But stay in the game. Like this stuff is very doable, I think. You see the differences between N's and V's. The only equation I know that has like N and V in it wrote is N equals C over V. So then you've got 2 different N's, 2 different V's. What do they possibly have in common? That they should be going C. So then I can create my ratio and just say, hey, look, based on that, that means 1 over 1.5 should be the same as one over 1.5, but that would be V1 over V2. So what's confusing here is I want to almost say that it's like 1 over, but remember, it says, what's the ratio of V air? That's 1. N1 V1 into V2. So it's kind of asking me for the opposite of what I'm getting mathematically. It wants to know what's 1 over 2 for my velocities. Okay. We're going to cook through this. So this one, you were probably the person that overthought it, maybe, I don't know. What don't I need here? Wait a minute. The speed of this light in glass with an index of refraction, I started figuring out, like, why do I need wavelength? Like frequency, blah, blah, blah. Like, you just want to know speed. What's my equation? N equals Done, done. All right. So number 19. Doing number 19, N equals C over V. I don't need. This is one where you can actually go back to like honors, write down what you know. I know N is, I always know C, I know wavelength if I need it, but this is what's V? I don't need wavelength at that point. Number 20, last one. In the figure above, an object is moved from position A to position B. They've asked this several times now. It's converging lens. A is going to go from, I'm outside 2F even. I'm way outside the focal. This is going to be upside down, inverted, real, and small. Once I get in here, right side up, not real, virtual, and big. So this, the more you do these, I think the more it helps. But way outside of that, upside down, small, and real. Okay, your homework while we're doing class. Because I printed it out and it's one right now. Good talk. Love you, bye. Stop.